Hi everyone, welcome to this first IAM NXTGen Digital On-Site Insight. My name is Richard Rayson, Senior Consultant at Jacobs and member of the NXTGen Committee for the IAM. NXTGen works to help early career and asset management professionals to provide learning and education in the discipline, championing members' views, creating an engaged community and promoting asset management throughout industry. To do that, we provide a number of different types of events and experiences. Includes on-site insights. This is of course the first digital one in the current climate. You'll see us as we are now here on part of the Trans-Pennine route, about to enter the railway. We also do talks from the top, in which senior members of organisations give insights about asset management to our members. Other networking events and new methodologies such as hackathons, and have our own conference stream. Today's event is presented by the Jacobs team working on the Trans-Pennine route upgrade, and they're going to be taking you through how we've used asset management to really benefit the Trans-Pennine route upgrade by connecting different parts of asset management together. What you'll see at the bottom of your screen, there should be a little bar with a question mark and some speech bubbles. If you click on that, you can submit questions throughout. Please, there'll be time for questions at the end. We'll address all your questions at the end. So yeah, submit them throughout, and yeah, we'll get to them later on. And without further ado, I'll pass you on to Stephen Newell, who is the asset management workstream lead within the Trans-Pennine route upgrade.
Hi, good afternoon, and pleasure to meet you all virtually. First time I've done one of these myself, so it's an interesting and a new experience, and enjoyable so far. So hopefully you all enjoy this journey with us. So what I'll do is I'll give you a little bit of an overview of what TRU is and a bit about our team, and then we'll go into a bit more detail about some of the disciplines that make up our team on TRU. So the Trans-Pennine TRU, we keep saying TRU, but it's the Trans-Pennine route upgrade. It's a rail upgrade and enhancement program that runs from Manchester, Victoria to Leeds, and then on to York, calling through stations such as Huddersfield and Dewsbury. It's a mixture of new build and also a mixture of renewals of existing infrastructure. If you just click on next, please. It's got four sort of primary objectives. One is reduced journey time, so that's A to B to C faster. So faster times predominantly between Manchester, Victoria and Leeds station, and between Leeds and York and vice versa. So allowing people to commute between these major cities quicker and more efficiently. More trains, so more services running, longer trains, so going from 3 carriages to 6 carriages in some cases, and increased performance as well. So that would be timetable performance, but also performance related to infrastructure reliability. So can we make a railway that has less infrastructure failure and therefore less what we would call in railway terms service affecting failures, to basically your train turning up on time or within a reasonable amount of time of its arrival or departure. If we click next, please. It's a multi-billion-pound program. Currently over 700 people on the program. That's probably nearly going over to 1,000 now. It's continuing to grow, and it will continue to grow as the program develops. It's a very diverse program made up of different organisations supporting Network Rail. We also have alliance delivery partners split by east and west of Leeds, so lots of familiar names there like Arab Amy, Bam Nuttall. We've got Sistra, Volker Rail, Siemens. So there's pretty much a lot of people involved in this program. It's a very complex program, and then obviously all of the subs below that as well. In terms of from an asset perspective, we've got quite a lot of assets on the program, as you can see there, over the 110 miles of the route. A lot of that infrastructure is aging and has been maintained well over a period of time, but it is now quite it's challenging to maintain at the moment. So it is a part of the network that is very ready for an upgrade and an enhancement. And we'll talk a little bit more about that and how we're helping that as we go through. So if we can go on to the next slide, please. So won't go into too much detail. It's hopefully a little bit self-explanatory, but we just wanted to sort of show how we fit within the program. So you've got the sort of program management, Network Rail. So as Jacobs, we sit sort of within the client organisation, so providing services and functions to help Network Rail as the client organisation. So you've got the overall program sort of management function. We sit within what is the technical design authority within the TIE program, which is made up of various different elements such as requirements VMV. So those familiar with systems engineering will understand how that fits in. Safety, so TDM and CSM, the common safety method. The operations modeling, so understanding how we can actually model timetable, performance and improvements. Asset and information management, which is what we will talk about today, and interface management as well. Within the asset and information management teams, we've got some other core functions as well: lifecycle costing, reliability, availability, maintainability, and we'll also talk about performance, reliability, availability, maintainability, PRAM as well. Asset data, BIM and CAD, so that 3D, 2D environment, common data environment, how we share and manage information on the program, and also survey management. So what I'll do now is I'll hand over to our next presenter, and hope you enjoy the rest of this presentation.
Hi everyone, my name is Richard Rayson. Hello again. I'm also lifecycle cost lead on this program. I've been working on transparent route upgrade for 3 years. The last couple of lifecycle cost lead. And what we're going to do, we're going to go over to the model, and we're going to we're going to go over to our in situ environment, and we're going to have a walk down the track just towards some switches and crossings. The reason I'm doing this really is to tell a bit of the story around the lifecycle costing within as we wander down this railway environment. Essentially, one of our findings throughout this program is actually quite how much diamond crossover assets contribute to lifecycle cost of a potential project, and that diamond crossover is basically a piece of switches and crossings which enables a train to cross in either direction between 2 parallel tracks. Essentially, it looks like a diamond, but the cost of operations and maintenance of that asset throughout 100 years can be quite significant. And this is just one of the small findings that we've encountered throughout the TIE program. Now then, Network Rail have a requirement that any project of over £3 million value must select the lowest lifecycle cost option, or present justification to the route managing director, so a very senior person within the region, as to why it's been selected. This means that lifecycle cost must be considered at all times. It doesn't have to be based on lifecycle cost justification, but if not, then requires other justification as to why it's been selected. Essentially, the application of these principles is aimed at enhancing the financial sustainability of the railway, which just benefit to everyone, taxpayer and Network Rail. TIU is basically the first time this level of lifecycle cost analysis has been undertaken on a major railway infrastructure program. In this time, we've worked with Network Rail Advanced Analytics team using their proprietary tool to both complete lifecycle costing, but also embed it within the decision making of the TIE program. So all decisions on major project interventions are based on lifecycle cost, or incorporate lifecycle cost thinking. Essentially, what this means is we have a number of asset lifecycle profiles which are based on the data from Network Rail Advanced Analytics, and each one of these contains unit costs and different types and frequencies of interventions. Each different intervention on project is modelled using these lifecycle cost profiles and aggregated together to produce a 100-year lifecycle cost calculation. These are then used within reports, and what we do is it's every at points when decisions have to be made. So during the option selection, during different project options, we have actually produced reports stating whether the lowest lifecycle cost option has been selected, and if not, requiring justification to be provided to the route managing director. Other involvement is included actually, and this is one of our really big successes I think on the program, is that we've actually managed to incorporate lifecycle cost at the early stage during validation panels. So in a validation panel, the delivery partner gets lots of experts in the room to discuss the different options from a range of different perspectives, whether it be engineering, environmental, lifecycle cost, etc. Actually, embedding lifecycle cost into that process has shown significant value in contributing towards the decisions made. We've also been involved in modelling route-wide options. We've modelled over 10 route-wide intervention options. And these have been used to present to the Department for Transport during the business case work. I think this is really key. The application of lifecycle costing on this is really key. In that one of our main aims outside of supporting the project of lifecycle costing is actually to learn lessons about how to embed lifecycle costing as a process inside major programs. Because this is as I said before, it's the first time this has been done. This means that in future, as it gets better, we get more able to use lifecycle costing to make decisions, which will, in the longer term, lead to greater financial sustainability of the railway. So some real major outputs that I'm looking to create as part of this is also lessons learned and providing as much feedback and developing processes with Network Rail, which will mean that lifecycle costing is applied across all major programs into the future. Based on and following on from me, I'm going to pass over to my colleague Graham Hall, who's going to tell you a little bit about how we're improving the maintenance and operations of the route.
Thank you, Richard. And if anyone's got any questions on what Richard's just said, please put them into the chat and we'll deal with them at the end of the presentation. So over the next few minutes, I'll describe to you the journey the programme has taken to ensure the maintainer and operator's needs are being considered and subsequently delivered within design proposals. I'll describe some of the processes followed to get to the recently reviewed GRIP 4 proposals for asset maintenance that have been delivered for the location we were just at in the model at Miles Platting from the West 1 project, which runs from Manchester Victoria East through to Staley Bridge. The proposals recently agreed with the maintainer are reflective of a necessary transition from the current daytime working between trains for track maintenance to planned overnight possession working, which will be assisted by new fixed worksite lighting along the track running from Victoria Station through to Miles Platting. So changes like this in maintenance practices are being delivered as a result of good operations and maintenance engagement being undertaken through the design and construction process for TRU. And this engagement's been pushed heavily throughout the programme by the principal programme sponsor to help ensure on completion the Transpennine route upgrade delivers the reliable, maintainable and operationally flexible railway that the customers, both freight and passengers, desire, with the capacity to meet their current and future needs. So ongoing engagement has been facilitated via the Operations and Maintenance Development Steering Group meetings, held each period with key stakeholders from both Network Rail routes, maintainers and operators, interface leads present from the North and East route, which is part of Eastern region, which covers most of the route from York across to effectively Diggle, where the maintenance boundary is between the North and East route and Northwest route, which is part of Northwest and Central region. So as well as the Network Rail route operators and maintainers and representatives of their asset management teams, present at the O&M steering groups are the train and freight operating companies across the route, passenger and freight customer forums, as well as the Department of Transport and Transport for the North. And all of this helps ensure that appropriate requirements and design choices are developed progressively as the programme matures to meet both the Department of Transport's client development remit and the desired outcomes, whilst delivering an upgraded railway that is both operable and maintainable. So if you could move to the next slide, please, Blair. The PRAM team and others in the Technical Design Authority for Network Rail that the Jacobs team sits within have helped translate the department's development remit and its desired outcomes into tangible requirements for both railway infrastructure changes and those of railway operation. The outcomes TRU is being asked to deliver, as Steve alluded to earlier, are a 15% increase in capacity, more trains effectively, and the capacity to carry more passengers per hour with longer trains will see an increase in passenger capacity from the roughly 800 plus passengers per hour that we carry across the route currently to a future 3,200 passengers per hour, a fourfold increase in footfall effectively. Journey times are expected to be reduced by 15%, accompanied with an increased reliability for the system. So the assets are being pushed harder, but they're expected to work more reliably. And all of this comes with a reduced access provision to the railway. So how does this translate into something tangible that's affecting operations and maintenance? Well, if you see the table in the bottom left-hand corner here, you can see that currently, before TRU gets going, only 13% of the route is in category 1 or higher. But by 2023, when most of the interventions will have come to fruition, some 55% of the route is in category 1 or higher. And this will lead to a greater level of integrity being required within the asset condition and a more onerous inspection regime due to the increased tonnages and the speed of trains in the changed train service provision. So to provide direction to the delivery partner alliances engaged in design and build contracts to deliver the upgrade, a concept of operations and maintenance document was prepared in 2018 to reflect the needs of the railway stakeholders. And this document combines with a subordinate maintenance strategy you can see above, which combined help detail the current practices on the railway and a future vision for maintenance across the route corridor. Both of these documents were informed by a set of high-level health and safety principles agreed by the programme, Network Rail and the Office of Rail and Road, reflecting safety by design and other related initiatives. And these principles are to be followed when changes are developed and delivered across the upgrade. The maintenance strategy was also informed by some maintenance principles developed and agreed with all stakeholders on the programme. And from these documents and principles, requirements have been taken and fed into routes requirements and operations and maintenance transversal requirements applicable to all projects across the route programme. So on the next slide, please. On the left, you can see here two of the high-level principles and how they are expected to be translated into the designs. And on the right-hand side, you can see a hierarchical approach to access for maintenance that incorporates many of the maintenance principles. And this approach has been incorporated into both the concept of operations and maintenance and the maintenance strategy. The first principle here obviously being avoiding the need for staff to go onto the railway in the future to maintain it. And if you can't avoid physically going to the asset, well, site it as in a position of safety, not on or near the line, if at all possible, and so on and so forth. Next slide, please, Blair. So here you can see some of the inputs and outputs to the concept of operations, which was developed over a number of months and iterations and a series of very long 2-day meetings with representatives from both routes. And to the right, you can see a diagram that illustrates some of the detailed sections contained within the maintenance strategy. Both of these documents were produced in 2018 to reflect the program outcomes expected at that time, and they're both currently under review to reflect some of the changes that the government is requiring of the program announced recently. The next slide, please, Blair. So this next slide reflects the endorsement approach that's been taken by the program at each GRIP stage of design development. To pass a GRIP stage, the program sponsor was adamant that all design proposals needed the endorsement from the relevant routes, head of operations, head of maintenance, and head of route asset management. And this was to ensure that relevant consideration had been taken and provision made within design proposals for operations, maintenance, and long-term asset management needs. And on the right, you can see part of a West 1B's GRIP 4 access point review document with the considerations made at miles platting for both West 1A line speed improvement works and a parallel project called West 1B, which is the electrification works running through miles platting, starting at Victoria Station and continuing through to Staley Bridge. And then finally, the last slide, please, Blair. This illustrates the many aspects of the PRAM team, which I lead, and the activities the PRAM team undertakes across the programme to help inform designs on the issues currently causing pain to performance of the infrastructure and the impacts design proposals may have on future infrastructure performance and maintainability. So as we return to miles platting and the model to hear more on our modelling and analysis from Aaron and Blair, I'd like to remind you again, if you've got any questions on what's been said so far, please put your questions in the chat for us to respond to at the end of the presentation. And I pass you to Aaron Johnson.
Good afternoon, everyone. So yeah, my name's Aaron Johnson. My role on the Trans-Pennine route upgrade is to undertake PRAM analytics, and as Graham and Steve have mentioned before, PRAM stands for performance, reliability, availability and maintainability. A core role within the PRAM team is the modelling activities which we undertake to assess whether design will improve performance to the passenger. So in the railway, performance is measured in delay minutes, which is the difference between the actual arrival of your service versus the scheduled arrival of the service. And I think a lot of us on the call have probably experienced delay whilst travelling on a train before. With that, I'd like to use this opportunity on the digital on-site tool to talk to you about a particular asset which causes the most delay on the Trans-Pennine route upgrade as an asset type, and is arguably one of the most recognisable assets in the railway, which is the track. Now, on the face of it, track seems probably quite simple, but actually it comprises of 3 different elements that most people probably aren't aware of outside the industry. So one is the track bed, which is what the rail lays on, which is the ballast. So ballast is the stones you see, often see around any railway network. And then also the sleepers, which I think we're all familiar with. Then also we have the running rail, which is usually made of steel, and you have different grades of steel. So you can have that steel gets harder the more it's used. So if you have more trains per hour, you'll see that in that area the steel is a higher grade. And then the last element is track fastenings, which is essentially it keeps it all together. Because we've got these 3 different types of elements, that means that track can fail and cause incidents in different ways. Depending on the incident, that has a different likelihood of causing a different amount of delay. But having said that, when track does fail, it's quite common for it to be reported in the same way, and that is from the train driver. So on a typical track incident, what would happen is the train driver will be driving along on the track as we are now, and they'll experience a loud bang in the cabin. And usually when they hear a loud bang, that indicates that there's a fault with the track. And when that happens, they phone it in to Network Rail and say, I experienced a loud bang. What Network Rail will do then is, because they can't go on site there and then and shut it all down because we've still got trains to run, they'll impose something called a track speed restriction, or a TSR. And a track speed restriction means that until Network Rail go on site to inspect what happened, it means that all trains that go through that area of track will then will have to drive at a slower speed. And as you can imagine, if that's going on, some of these can last for weeks, depending on the time they can get on the track. That can cause a significant amount of delay. So with that, with these types of incidents, what we do in the PRAM team is we look at the hotspots. We call it a hotspot. So where these incidents are most frequent on the network and cause the most amount of delay, we use that information to inform the designers to ensure that those assets and those areas are targeted for investment. And then we go a bit further than that. So that gives you what's happening today, but we also give a forecast on the future, which we achieve through looking at the wider network and look at what we call case studies of where Network Rail went in to intervene. So they did a renewal or a refurbishment, for example, and we look at the delay, average delay per year of that asset before and after, and that gives us a level of improvement. And that level of improvement we feed into our model to give an indication of what the Trans-Pennine route upgrade will look like in the future after we've delivered our design. Up till now, I'd say up till probably about Christmas, we've been doing something called option selection, which is grip free in the railway. And that means our modelling activities have been quite high level, and we look at different options. So that would be one option would be a discrete amount of railway, and it'll have it could be full electrification, and then you would have a second option in the same area which could have no electrification, for example. And we'll do modelling activities on both to see which one's the preferred option from a PRAM point of view. As I say, this is quite high level. Now, this year and going forwards, we'll be going into something called detailed design. So that means that we've selected our option that we're happy with, but we need to provide some insight on an asset level of how well or badly that asset's performing. So with that, we've started to implement machine learning, and this has only been, we've only been allowed to do this recently because we've established a central data warehouse, which my colleague Ross will be speaking to you about later on. But with this central data warehouse, that collates a lot of data, more data than we've seen previously, but also bring in external data such as from the Met Office, so we can look at temperature and weather and see how that corresponds with when track fails, for example. Because again, going back to track, during summertime, they can buckle. So steel expands when it gets to a certain temperature. They start pushing against each other, and the track buckles, which again cause another incident. Which is why it's important to feed in this external data, so we get a more complete picture of what's happening on the railway. So with that, I'd like to now move away from the 3D model, which does look really good. So apologies for that, but I'd like to talk through to you about the machine learning outputs and just give a good example of what I mean in terms of what we are doing on the TransPennine route upgrade. So we've got a slide open here. I'm going to, the first one on the left, it's going to be a 2D visualization of what we've just seen in the model. And I've highlighted a piece of track there. So as you know, track is a linear asset. So from an asset management point of view, we need to break that down, and it needs to be maintained in parts. In the railway, it's traditionally broken into 1/8 of a mile track sections, and that aligns to the level of detail we model to. So I've highlighted this piece of track where we were on the 3D model. And then the first part is to understand, is this piece of track performing worse than what we've seen before? So going into the next block, we can see the delay now. So you've got average delay in minutes per year. So this piece of track, this 1/8 of a mile of track, is causing 93 minutes delay. Compared to the average for TRU, which is 48 minutes, you can see there's quite a big room for improvement. And so from a PRAM point of view, would say that's quite high. We need to focus on this. We need to make this better. The machine learning first gives us an output initially detailing which are the potential leading contributors, the causes of delay, if you like. And in this case, the top two are tonnage. So when we say tonnage, we mean the number of trains per hour, or utilization, if you like. And then the second one is asset condition, which is how old it is. So this gives us a good idea that, so we've got this 1/8 of a mile track section. It's performing not very well. And the reasons for that is due to we're using it quite a lot and it's got poor condition. So with that in mind, what we can do and what the designers do, they run a scenario. So if we go on to the next part, thank you, Blair. We can see, right, okay, so we know what's happening now, but what about when we come to deliver TRU in the future, in 2026, and we have that timetable that exists then. So in 2026, we're expecting 2 more trains per hour, which again was covered before with from Steve and Graham, which means we expect the asset's going to be used more. But then what if we renewed this asset? What would that give us an improvement overall? So when we run this scenario into the machine learning model, and with the machine learning model, it undertakes these scenarios in a matter of seconds. It gives us an output as follows. So you can see that with the 2026 timetable, tonnage is going to cause more towards the delay this asset's going to cause. But then the renewals had quite a big significant improvement with the asset condition. It's improved quite a lot. So this is all good, but the final output, what the designers want to know is, well, okay then, well, what about the passenger? Because they're the people who matter. What will they see? So we give an assessment of before and after in terms of delay. So before we're seeing 93 delay minutes, but actually with this scenario, if we did renew this 1/8 of a mile track section, we would expect at most it to be reduced to 56 minutes. And you can see that there's an interval there with a 90% accuracy. That is to do with the model. So it seems like actually in terms of the investment, we're going to get quite a good improvement here. So this is probably what we should be doing. Now, hopefully, we could speak quite a lot more about this, but given the time, we can't. But hopefully this has given you a nice snapshot, a nice taste of what we've been doing. Another key point really is at the moment this is informing design. The aim is hopefully we can make this more an O&M decision support tool as well. So for the maintainers, because in this instance we can see that although we've renewed the asset, when it fails in future, it's probably not going to be due to the condition, and it's probably going to be more due to the amount of trains, which means that we need to assess whether our maintenance regime's fit for purpose. Now, what complements the modelling activities and the outputs nicely is the colleague is going to follow after me, which is Blair. What he's been undertaking activities to look at the underlying root cause. The modelling activities I've shown here are very output driven, as I say, delay before and after, and they give you some indication as to what the cause might be. But I think we all know as asset managers, it requires a lot more detailed investigation to understand what the true underlying root cause is, which tells you the why this delay is happening in this area. So without further ado, I'd like to pass on to Blair. And just sorry, Blair. Finally, please, any questions, put them into the Q&A. Okay, thanks.
Thanks, Aaron. So as Aaron said, my name is Blair Whittaker. I also reside within the TRU PRAM team, and I'm a reliability, availability, maintainability, and also I do a bit of system safety as well. So as Aaron said, the work that he's been doing with this wonderful modelling gives us a snippet into the future on what could be and what we could expect to see. But to help start the process, the design process, we wanted to understand what are the known problems and what are the current issues. So in order to do that, we undertook a root failure modes, effects and criticality analysis. Now, traditionally, a FMICA, as they're called, or FMIA, as it may also be termed, are used, undertaken by a team of technical experts, operators, maintainers, and they lock themselves in a room and basically go through every single nut and bolt of a component, an asset, a system of systems, and establish every way that that could fail, how it could fail, why it could fail, and the effects of that failure. Now, where that is not replaceable, we felt that in TRU we wanted to take a slightly different approach. Within our role, we obviously are in the program management team. We wanted to give a bit of direction, and our assessment was to be high level. So in order to do that, we decided to take a data-driven approach. So instead of locking ourselves in a room with every technical expert on the route, we decided to turn to network rail data. And from that, what we've been able to do is assess 70,000 failure incidents, which apply to over 50,000 different assets, and that has allowed us to identify the known deficiencies on the route. Now, by identifying these known deficiencies allows our designers or the design teams to start, have a look and understand what failure modes are occurring, what ones have had the biggest impact, and start their design from there. So to do this, we've used key network rail data systems, such as the failure management system, which logs all faults and failures. We've looked at the trust system, train running over tops, which is total operations system, I believe, and that is basically where they get how the trains run, if they're late, if they're on time, and this is a delay attribution. This is what their key metric or key area for capturing performance data, and ellipse, that's their asset inventory and maintenance scheduling tool. From when we get this data, what we've been able to do is evaluate it and understand it in such a way that we have used the frequency of these incidents to get, again, a probability of failure, and then the impact using delay minutes to understand how bad that impact would be for these failure modes. Again, when we've done this, it was quite a lot of incidents, quite a lot of assets, so we had this verified and checked over by the route maintainers and operators, and they felt that this was a good representation of what they've done. So you can see on the left, on the right here, that just a dashboard output of the route FMICA, and this was just a way for allow the designers and others to just quickly access the information. So I'm going to give you a quick example how this could be used. So again, looking at same dashboard that we can see here, we can select an asset. So this one, I've just picked the top one for the area. So I've selected project multiple selections, which is roughly the area you've seen on our Insight or Onsite Insight. So this one is a point operating equipment. So that is basically the mechanical electronic system, or sometimes even hydraulic pneumatic system that allows the switches on the track to move. And we can see that this one has caused 4,843 delay minutes for this specific asset. Now I've got and what we can see here next is looking at the key failure modes down here. So this one, I know because I've obviously made this tool, but that this is a clutch insulator plate. The clutch insulator plate has obviously failed in this asset, leading to this failure, and it's at a key area on our route. So therefore, if we can't use the switch, we can't manoeuvre trains in and out of certain areas. We also have a couple of high-level dashboards to show the proportion of this failure against the system. You can see in this area that the majority of the issues are related to signalling, which this point operating equipment is part of. And finally, we can see here the proportion by failure mode. So this is, as you can tell, with the largest incident, the most significant failure mode. However, this tool kind of looked at the past and a set of data that was static and allowed us to begin our design process and allowed the designers to take a deep dive and understand these problems more in depth. So what we're going to do now that we're starting to design, we're potentially starting to construct, test, commission and put in place. So this is the next tool that I wanted to talk about, which is DRACAS. Now we've created this DRACAS system. Again, we've called it data reporting and corrective action. You may have heard this in slightly different guises, such as FRACAS, which is failure or fault reporting and corrective action systems, or defect reporting and corrective action systems. We've decided to use the term data because it's a wee bit more encompassing and because we're obviously taking a very data-driven approach. Now, within our DRACAS system that we've envisaged for TRU and we're trying to implement, we've broken into kind of 3 distinct components. The first one is a trend analysis and performance monitoring. The reason we've done this is because TRU, as it is, overlaps a few different regions within Network Rail's organisation. So we've got Eastern Route and London North Western. And that doesn't allow us to have one continuous view of the route from Manchester, Victoria to York. So we've created this tool to allow us to do that. And from that, we have able to determine 3-4 key performance metrics. So the first one is delay minutes and cost. So our goal is obviously to improve the performance of the railway for the passenger, and that's delay minutes. We don't want trains to be late. So again, this metric just shows that time over trends. You can see on the x-axis here is periods. Periods are 4-week reporting cycles within Network Rail's business organisation. And we can have the cost against that as well. The next one is number of incidents. So it's important for us to understand the number of incidents that are occurring, and we've broken this down by different systems. So you can tell that some of them haven't been able to be attributed to systems the way we've got now, and that's just due to connections within our data. So that's important to allow us to see where the problems are occurring. These are not all service affecting, so sometimes we have incidents that don't cause delay to trains, but they're important because the more it fails, the more probability that could lead to a service affecting failure. The next trends we've kind of got is mean time between failure. Now this is important. It's a more traditional reliability kind of metric and something that you would traditionally see on rail projects. We've slightly moved away from this, but the reason we included this in our DRACAS toolkit is because TRU is a complex and phased program. We're not just going to turn the railway off, do all the work and turn it back on. It's phased over a long period of time. So we need to realise the growth and the reliability improvement and performance improvement over that time. So this allows us to show and demonstrate a reliability growth. Again, similar to MTBF, we've got MTB SAF, which is mean time between service affecting failures. And similarly, this is just those failures that result in a delay minute or delay cost. And again, this is to help us show that we're improving with time. So moving on, the next section, most important, is our performance or program introduced performance impact. Now this is probably the core of what people would expect DRACAS to be. Now this, as the kind of title of it implements, is what we do as a program during the design, the construction, the testing, the implementation, the hand back to maintenance, and potentially also the rest of the life cycle of that asset to decommission. We want to understand what we have done that's good and bad and improve that. As a program, we have a duty to, or are accountable to ensure that the impact of our work does not affect we have to minimise that effect on the passenger during our programme life cycle. So this is to help us collect and examine the performance information. So we wanted to look at things such as possessions. So possessions, when we shut a section of the railway to do some work overnight or at a weekend, etc., understand the work that we've done, and it also complements some of the work that we've done elsewhere, so other lessons learned programmes, such as design close calls and can't remember the one, lessons learned, just general lessons learned system we do. But the most important thing is this is done on a periodic basis, so every 4 weeks. So this review and collection of this data so that we can understand on a timely manner. And the last bit, which is fundamentally the most important part in my understanding or my belief, is the corrective action. So this is where we use the expertise of those around us, from the maintainers to the operators to designers to planners, all these technical experts that come in and perform functions that make sure our railway runs smoothly and effectively. We want them to come in and help us understand why these issues happened, whether that's a failed asset or a defect in an asset, whether it's a possession overrun or whatever that issue may be. We want to understand that. We want to kind of develop a robust, sound solution and apply it. But again, as I've said, we've taken a very data-driven approach. We want to store that data. So when we collect this, that we devise the solution, we want to connect it to that asset, to that timestamp, to that incident. And therefore, when that occurs again, we've got a ready-made solution that we can apply, or when it's about to occur, we could apply again. And we're only ever going to go back into that solution to help say, is this still the right thing to be doing or improving? So with that being said, I'm going to ask Cameron to jump back onto the model for us, and I'm going to give you an example of what the performance introduced or the program introduced performance impact may look like. So when we're on the model here, you can see we've walked through it, and hopefully you've kind of been in as much of it as I am. But when you see all the red here, this is generally stuff that we plan to change or put in or propose. So when you see the area here that we've got, there's a lot of red, specifically the overhead line equipment, which is the electrification system that allows us to run electric trains in this area. Now you can see that this is quite a bulky and considerate about information, or consider it asset. So in order for us to install this, construct it, we have to take possessions of the railway. So we would take a big chunk of the railway for 8 hours, and these can cost a considerable amount of money, millions of pounds. So first of all, we want to understand, are we doing every conceivable amount of bit of work that we're doing in that area? Can we do more? Are we doing everything we can do? And then secondly, we want to understand, if we take that possession for 8 hours overnight, and at the end of our 8 hours, we still haven't finished the work, and the first trains can't run in the morning, causing a delay. So that's causing a performance impact to the passenger. We want to understand why that happened and how we can improve that, so that the next time we take a possession, that we do not have that issue. Also, as you can imagine, with massive construction jobs like this, there's going to be bits and bobs that just never ever get finished. So that will comprise in a snagging list, and we want to understand what are going to be the things on those snagging lists, so that the first project that we do this kind of works on is our test bench. We understand the problems that arise and the issues that we've developed, and from there the kind of follow-on projects don't have these same issues. So again, as I've said, all of this is data driven, and none of it is really possible without having a connected environment, a connected data environment, and a way of visualizing it and understanding it. So with that being said, I'm going to pass you over to Cameron, who's going to discuss this amazing model you've seen. And just before I go, again, if you've got any questions related to the route Formica or Dracas, please put them in the chat, and we'll do our best to answer them at the end. So yeah, thank you very much.
Thank you very much, Blair. So as Blair said, I'm going to be talking a bit about the I model, which is what our visualization tool here is called. So all the model that you're seeing here, it's all brought through from our common data environment, where all of our CAD modelers work, with other workflows, etc. And what it does is it brings all of that information up into the cloud server here for the AI model, and it presents it all for us. So all you need is an internet connection, correct permissions, and you can come and see this, CAD personnel or non-CAD personnel. So it's extremely easy to share with just about anyone on the project. And the main thing about this, as we've all said, is this isn't just a pretty picture, it's data rich. Every piece of this model has, you know, tons of information assigned with it. Now, one of the things I wanted to kind of show off is some of the functionality that this has. Again, both for CAD personnel and non-CAD personnel to use for things like IDCs, IDRs. And one of the first things is the issue resolution feature. So this is for identifying different technical issues with CAD. So let's say, you know, we're coming in to do one of these reviews and we notice that there's a technical fault here, there's a clash. Open up our issues resolution tab and we can assign it with just a couple of clicks. So there's just like the area for our different issues, opens up a form for us to describe what this issue is so that anyone who does come along, you can easily identify what it is. So just throw in some placeholders here. The date we would like this to be analysed or reviewed by, stats that it's sitting at, and whoever we're assigning it to. Now, anyone this does get assigned to will get notification through their connection client and also an email. So there's no chance of just these issues getting lost in the ether. Inscription there, and we'll save it. Now, one of the powerful things about this issue resolution feature is that, you know, you're not going to have one issue in here. You're going to have a list of issues. And the power with this is it saves a little thumbnail there for you. So let's say we're in a totally different part of the model, but we're looking down this. We want to come and check each of the different issues or anything against them. With one click, it will zoom us right back to the location of this exact issue. We can come and click in and say, okay, here's what it is. Here's the issues with it. How do we resolve this? And then once we've come and done it, edit, and we can close the form. Simple as that. So in terms of technical issues, IDCs, IDRs, you know, the ability for anyone to come in and see this without having to have, you know, a super powerful computer with the correct software installed is immensely powerful. So that's just one of the tools that we have, issue resolution feature for any sort of technical CAD issues. Now, another feature we have is called the safety base. Now, this is less technical issues and more for, you know, safety hazards and things like that. So again, with a couple of clicks, we can come and open up our safety base. Slow down a little bit. And there we go. And what this allows us to do is see any of the safety hazards that people have assigned to this model, and similar with the issue resolution tool, see exactly where they are and see exactly, you know, the description, any of the information behind that hazard. So give this a little second to pop up for us here, and we should see everything pop up just here. So as I said, we have different locations of hazards that have already been identified. Again, this can be across the entire model, and we can, with just a couple of clicks, go and visit each one of these. But for argument's sake, let's just come and have a look at this hazard right here. I'll open up a separate tab for us. And within here, we can see information like the severity of the hazards. We can see all the descriptions against it, who created it, when did they create it, what area is it sitting in, what asset is it assigned to. Again, we can assign this anywhere in the model we like, and anyone with the appropriate permissions can come and assign this sort of stuff. So when you're doing your IDCs, IDRs, technical issues, sorted, any safety hazard issues, sorted as well. So yeah, as we said, easy to use, come through, anyone can use this. And the last sort of thing I want to quickly touch on as well is, you know, as we've said multiple times, this isn't just a pretty picture. There's an unbelievable amount of data stored in this model. And I'll sort of show that off to you right now. So I'm going to come and look at our bridge asset here. And just as an example, we're going to click on this concrete beam. and straight away we can see all the asset information assigned with this. Scrolling up and down. And one of the powerful things that we have against this and against all of our assets is a unique asset ID. So say we don't only want to look at this concrete beam, we want to look at this entire bridge section. What we can do is we can come and look at the unique asset ID that's been assigned here. And we can find all that are similar. So let's do that. And what that will do is that will search that unique asset ID against all of the assets with that attribute assigned to them. And one of the cool things we can do within this AI model is we can select all of these assets. And we can hide them, or we can isolate them. What that allows us to do is, again, it's not deleting any of the model at all, it's essentially just hiding it all. So if we have a certain part of the model that we do want to isolate and analyze, we can easily do that. And this will work for any part of the model. Again, they'll have these asset IDs assigned to them. So yeah, we can do that and look at any part of this. And the very final part of the sort of data journey with this as well is that, along with isolating different parts of the model and being able to search against these asset and attributes, we also have a report that bounces off this as well, a dynamic report. And I will let my colleague Ross speak more about this.
Cheers. Thank you very much, Cameron. Thank you for that. If you've got any questions about that section, throw them into the question box. But I'd like to go on to my section now. So good afternoon, everyone. My name is Ross Chapman, and I'm the Asset Data Specialist on TOU. I specialise in data storage, data manipulation, and today I'm going to talk to you about our data warehouse. It's something that a few of us have mentioned, a few things what it is. I want to give you a bit of an overview of what these things are. So as you can see, Cameron here has brought up this one asset, and on the left-hand side here, we can see what's that 15, 20 attributes about that asset. Now, if we take a step back and go, okay, how many assets do we have? How many attributes do we have? So on TOU, we were analysing around 100,000 assets in the system, 120,000, and Cameron's just going to bring us. So immediately there's 15, 20 attributes. Now we're talking 150, 200,000. That's great. We've got two big bits of data. That's something that we can always probably handle in a decently managed Excel spreadsheet. But now obviously Blair's mentioned trust, FMS. We have work orders. Each of those work orders against an asset will have events. And actually what we have in our ecosystem and all these data is millions and millions of lines of data in this data warehouse. And what I thought today was, rather than going to give you a bit of introduction about go into the technical detail, I thought I'd give you a bit of an overview of what a data warehouse is, what it means, and really what we're talking about when you hear these buzzwords out there, and how it can really empower your asset management decisions. So can we flick back over to the PowerPoint, please, Blair? Thank you. And thank you, Cameron, for showing off the dashboard. So while they're flicking over, we're going to talk to you about a nice analogy here about filing. Probably a good sort of thing to do. So I'm not saying that the data we have is a filing case, but I thought it's a great analogy of understanding it is. So what we've got here is, why don't we consider each system as a filing cabinet in a building, rather than as a database on a server. Now, some filing cabinets, there's lots of different ones. Some of them are together, some are disparate, some are bespoke, some are standard, and some may be outside. So if we pop up the graphic here, we can see this building here. We've got a couple of very well built, very well specified assets, the two matching ones there. We've got a lovely bespoke handmade wooden one, and we've got a cardboard box full of files out in the car park. None of these things are necessarily bad or good. We're not here to talk about whether they're good or bad, but what we're saying, this is common. You've got data everywhere. There's things stored everywhere. But on TOU, we've got a big collection of data. There's over 60 systems that NR have. We're not connecting to them, but we're pulling in data for all of these. How can we optimize this? So can we go on to the little the next slide, please? So our approach is quite simple. First of all, we transition it all into central cases. So we run some very big scripts, pulling that data around to central databases. Then we standardize. So a couple of those now flip and we change their format. So when we say standardize, we make things into common language. So that cardboard box is gone. It's now appeared that bespoke one into that nice colored, multicolored cabinet there. The next thing we do is union. Union's a bit of a database term, but in essence, union means copy and paste and put it on the bottom. So we make our data very big, very small. So we have standard data. I don't mind if assets come from a spreadsheet, if they come from a big system like Ellipse, which network we use, another database. We get it all into one big database so we can give it to people like Aaron and Blair to run their algorithms. The next key step in our process is to connect these ones. So these are data joins, and I'm going to talk about this more. And then we index and understand. These are two things here. And there we are, literally a 1980s reference to index there, the only decent bit of clip art I could find to explain that one. But these are all a bit buzz term. What does, to us, the key thing for TRU is this connection, this indexing and understanding. Now, what does that mean in this filing analogy? Just move on to the next slide here, please. Thank you. So the first thing I want to talk about is understanding. So a good question here. What was the weather on the train journey last Tuesday? So if you go back to that filing analogy, a filing assistant could really easily, they could go to the calendar and go, what was the date last Tuesday? They then go into the train system, look at the logs. They can find out where that train was last Tuesday. They can then go and look at Met Office with that data and find that weather. That's a very one-to-one relationship. Something that your filing assistant can do, and do that as a one-off. And yes, you could do that if it was a one-off query. But what the key thing is, with that understanding, we've understood those joins. Can we apply a similar set of joins and apply them to big ones? So the next bit here, I want to talk about connecting. So similar sort of bits of data. We want to go and slightly change the question here. What trains were moving when the temperature was below 0 degrees? So similar components here. So really we start off with the Met Office. We go into the Met Offices and we find all dates and all locations where the weather was 0 degrees. We're talking about a lot of data very often, very quickly. Then it gets exponentially bigger again. We have to match that data to the locations of track. So we're out of the reams of a filing assistant here. We're now into the reams when we're connecting it. We then have to go into trust and connect it, all those trust, and get those train locations and dates and fill it and filter it. So what we're saying is this understanding and connection allow us and empower our calculations. So these sort of elements we're talking about here, we call these data tables, and these are data connections between them. So I thought I'd give you a little overview on 3 of the key elements that our data warehouse is made up with. So on to the next slide. So our 3 ones are assets. So assets is the most critical part of our asset management journey. On TRU, we've mentioned here, we've got over 100,000 things in our database. This is just but for us, in our way we structure this, is we structure this just a list of things. All we want to know is what it is, a unique ID, where it is, and its current status. When it comes into data about it, so the length of track, the size of it, we pick that in a different table. Now this is different from what you might see in spreadsheets, but we put this in a separate table. I don't necessarily mind if it's from a database point of view, whether it's track, whether it's a signal. What we do is we have a very simple list where we have multiple rows for each asset with a line per attribute. We can use, in the Excel world, it'll be a VLOOKUP, but we can use database joins to pull that across. What that means for me is I don't mind if someone wants to add in a new attribute or remove attribute. To me, it's a new line on the database. I can pull that across. We can scale up to whatever it is and whatever specification they want. So whether they have 10 asset classes or in the case of Network Rail, 1,500 asset classes, I don't mind. We can account for that in that one table with just 6 columns of data. A lot of rows, but just 6 columns. On the other side, the key data element is events. So when we start expanding this logic, we want to talk about events. So the events are actually, to me, very similar to assets. It's a list of things. And an event to us, some people might say planned work orders. They might say reactive work orders. But in a database, we mentioned that word standardize earlier. To me, and in that database structure, they are just a thing that happened on a date. The thing has attributes and the thing will have a type. But if we think about the storage like that, we can genericize and standardize, which means people like Aaron and Blair can connect into that and start not having to build multiple different ways of connecting. They haven't got to build lots of different sheets and often different ways. There's a lot of efficiency in the scale of what we can do with it. Now, for those of you who have ever looked in the back end of a system like Maximo Ellipse, this is a really similar setup to what you find in these leading CMSs. People like IBM and those have got this similar sort of setup of attributes and tables that helps found these major asset management decisions that we've used. Could you pop onto the next slide, please, Blair? Thank you. So we've mentioned these 3 tables. These interconnect. And with these interconnections, they don't just interconnect, they interconnect across a lot of tables and across throughout the network. So there we are, some other tables, these other key elements that we've talked about today. So we've talked about events on the right, we've talked about FMS and trust. These all interlink on lines. We've got an asset data dictionary. We relate those ones. Actually, if I was to step out with all the lookup tables and all these connections, there's over 100 tables that we've drawn and joined in and use automatic scripts to do. Now, it sounds like a lot of maintenance, but it's automated. Once you've come up with that connection understanding, we can replicate and do things very quickly at scale, which enables Aaron and Blair and Graham to do the work for the task they want to do. Now, I wonder if we could flip back to the model now and give you a bit of a real life example of what this looks like and kind of put this back to where we are. So hopefully, Karen, can we flick back to the bridge we've been looking at? Thank you. So as we can see, with the bridge here, and just near the bridge, oh, sorry, Karen's just loading that up. So near this bridge, there is an access point. So I'll allow Karen to do that. So as Graham has mentioned, access is a key thing, but understanding maintainability of access, we want to understand how long it takes someone to get to an asset. And it's not like with the rail, there's extra restrictions. It's obviously, there's trains, there's a safety connotation, there's a big fence around the structure. We need to think about how we can get to that. So as this model is loading up here, you'll see this access point coming up here in the foreground, roughly where Cameron's mouse is there. Now, in this little location here and this sort of spot around this bridge, it's quite easy. So as that loads up, the bridge is right next to an access point. It's 20 meters away, 20 yards away. Yeah, going back to that filing assistant analogy, it's very easy to understand. If I want to maintain that bridge, I go to those steps. I've got a distance, so 20 meters. That's my time from where I need to connect and walk across. Now, that's brilliant if you want to know one asset, but the network rail, the railway project that we have is significantly longer than one asset. This is how can we answer this question at scale? So we've thought about different ways, and we've used Python and we've used other scripts doing, but what can we use the data warehouse to really empower it? So what are the logics here? So, okay, it's brilliant. I might want to reach that bridge here, but what if actually this is good? This is, as you can see, it's loading up slowly in the background. There we've got this is steps. There's no use going up steps if you want to get a car onto the railway or a railroad vehicle. You want to get access via a track-based vehicle. You're not going to be able to go up steps. You're going to have to go a different way. What if there's a blockage? So an incident has happened to the east. I need to come to this area from the west. How do I overcome this? What data do I need to do this? Okay, what about, I don't want to, actually, we've talked about this bridge. What if I want to go to the left? I want to go to the overhead line to the left, a few meters to the left. I want to go somewhere else. I want to continue these different assets. We thought, well, actually, there's loads of different combinations of how you can want to answer an asset. And there's loads of questions you weren't asking. So I thought, rather than waiting for someone to ask me the question, how can we use the data warehouse to answer this question? So what we did is we separated the rail, the project, into 1 yard units. The railway works on a system of ELR and mileage. Those mileage is separated into yards. So it's a common unit of measured. And yeah, 1 yard for scale is roughly, you can see, and there's a fence there. It's roughly equivalent to each one of those fence spaces. So we separated the whole unit into those 1 yard sections. For each of those 1 yard sections, we then matched that 1 yard section to every single access point. We worked out every single combination. Roughly 200 million. Now, with the power of a decent spec server, it took us about half a day to work out how to solve the problem. But now it takes 5 minutes to rerun, work out those 200 million combinations. Whenever we find a new access point, the designer comes up with a new one. They find out we've missed one. They found a bit of extra information. We can recalculate that data. Now, what does 200 million? It's a big number and it's nice and it makes me quite proud of the database to say. But what does that actually mean for people like Aaron? Well, with those 200 million, they don't have to worry about what is the best way of answering it. They can look at the second best, the third best, the fourth best. They can look at access from the east, from the west, up the rail, down the rail, left-hand side rail, right the rail. They can review that for any way. They can look at, okay, if I routed traffic in a different way, what is this one? We're not just presenting, my job is not just to present one option, it's to present Aaron and Blair with a data set that enables them to model all the options. And that's a key thing. Those data connections and that data understanding allow and empower people like Blair and Aaron to do their analytics. Thank you, Cameron, for spinning us around that access point there. I wonder, Blair, can we quickly flick back to the slide deck now? So we've talked about the data warehouse, and the data warehouse is, and we've talked about lots of other systems today. So on the left-hand side here, we have the data, in this inner circle, we have the data warehouse. We've talked about the model hub, and you've seen a lot of visualizations of this. We've talked about the decision support tool on the left, another visualizations tool. But this is not just all we do. It's part of a wider journey. We're thinking about what are these other things we can do on TRU. So we're talking about aligning to these other areas. We've got tools that we've put onto this. Now, this connected ecosystem has enabled some important conversations and some critical discussions. I'm now going to pass over to my colleague, Stephen Yule, who's going to discuss what these connections and these discussions have enabled us to do. And as always, if you've got any questions about this section, chuck them in the chat. And thank you very much, everyone.
And thank you for that, Ross. Appreciated. So Blair, moving on to the next slide, please, if possible. So what I'm going to talk about is how we've sort of built upon what Ross has just described there as our sort of today connected environment, moving towards a vision of a digital twin on the transparent boundaries upgrade. And by the way, just for those, it was a little bit of a while ago now, and I'm not completely sure I introduced myself at the start, but yeah, sorry, Steve Yule. I look after the asset management and information management teams on TRU. So digital twin, it's an interesting one. It's a very hot topic at the moment in many different sectors. There's a lot of hype at the moment and a lot of noise around it. So what we're going to do is just try and talk through how we've gone on a bit of a journey at the moment, and how we've gone on a journey in the context of the railway and TRU. So our approach has evolved organically over time to meet the needs of TRU. We didn't set out to start working towards digital twin. We, as Ross described and others, we've been very sort of output focused, outcome focused. We're trying to solve specific things that will help TRU meet its core objectives and deliver the railway service, putting passengers first ultimately. We joined the asset management and information management teams together. So we've taken asset management and we've joined it with BIM, Common Data Environment, GIS. What we found, we talk within asset management a lot about tribes and about people speaking different languages. Well, one thing we found with information management is we actually speak a lot of the same language. We take a life cycle view. We talk about data, we talk about information, the connectivity of that and managing it throughout the life cycle. So we found that there's a lot of synergies there. We've also focused on making information accessible, and that's information accessible at different elements of different stages of the life cycle, but to also different people. So an engineer may need certain information, an asset manager, so somebody working on RAM or PRAM may need certain information at certain times in different ways, but also HR or communications might need some information. So maybe if you're doing some comms, how many structures are there on TRU? It'd be surprising how hard it is to find out that kind of information sometimes, and who you have to go and ask. It's not readily available. So making information accessible to people on the program. A single version of the truth. We have multiple sources of truth, but for TRU, one of our cornerstones is having a version of the truth, a single version of the truth that people can rely on and trust. As soon as you start getting different versions of the truth on a program, that trust in the data and the information breaks down. So it's one of our core objectives as a team is to make sure we are creating a single version of the truth that people can depend on. A digital by default approach goes without saying. Joining the dots, a lot of what we've done, particularly on this last slide that Ross showed, was to really just join the dots between things. There was, it was surprising. We were doing lots of things, making lots of progress, and it was only when we brought those teams together and we started having conversations that we realised, well, actually, okay, I could use that, or I can help you with that. And having those conversations, having that one team mentality has actually allowed us to go on this journey that I'll describe a little bit more on the next slide in a second. Started by accepting that change will happen. This is a long-term program. The client organisation outside of the program is changing and evolving. So when we've done this, we've realised that, well, actually, we've got to be careful, and I've seen it happen many times before, is we don't back ourselves into a corner with the approach that we take, that we find in a few years' time that things have moved on. We don't have the flexibility to adapt with it. So a lot of what we've built and created is on the understanding that things will change. So how can we remain current and flexible on that journey? And an open and collaborative approach. We work very closely with the alliance delivery partners on TRU within the wider network rail to share what we're doing and help others learn from it. And then we in turn can hopefully learn something back and improve and develop what we're doing. We've not set out on this journey thinking we know best, we know it all. We've accepted the fact that we're all learning as we go on. This is a rapidly developing area. So an open and collaborative approach we found has yielded some significant benefits. And again, all of this aligned to Network Rail's imperative of putting passengers first. So moving on to the next slide, Blair. I'm not going to give a talk around what a digital twin is or is not. I'm just going to give you a little bit of a flavour about where we are with it at the moment. So we've done all the good work again, as it's been talked through. We were then asked by the client organisation to prepare a digital twin strategy. Probably one of the first of its kind within the railway, particularly within the railway in the UK. So we didn't really have a lot to build on, and we haven't actually come across that many digital twin strategies in the wider world. I'll talk a little bit more about how we're interfacing with that sort of wider digital world in a second. But we've come up with the definition of a digital combination of multiple static and real-time data sources, analytics and visualizations to provide an enhanced understanding and insights across railway disciplines, systems and networks, all aligned to putting passengers first. So yeah, so that's our view of it. You will probably find other views of what a digital twin is and is not, but really what the graphic below tries to do, and the text beneath it, is show our interpretation of this. So a lot of what we're creating at the moment on TRU and what we've already created with the likes of IAM model, common data, central data warehouse, doing our decision support tools, would quite neatly fall into the category of what we call a digital replica, a replica of the sort of physical or future infrastructure in the digital world. On the left-hand side of this, you have the increasing data sophistication on the right, increasing decision-making capability, and then that's sort of the leading edge, moving from a digital replica through a transition period, as we're calling it, into a digital twin. Now, one of the important things, a couple of concepts just to mention now, and we could probably do an entirely separate session on digital twins, which I'm sure hopefully there'll be some interest in. But some of the things to think about: a bridge can be a digital twin, bridges can be a digital twin, the railway can be a digital twin, and I think the best way to think about it is an ecosystem of digital twins. So you could have a group of bridges as a bridge as a digital twin, or a group of bridges as a digital twin, and then you could have a separate digital twin that looks at signalling. And now these things may not be in the same digital twin itself, but they should be able to share information, data between them, then creating this overall ecosystem of a digital twin. And the different elements within each of those different ecosystems can go on their own path of development. So when you look at the diagram in front of you, all different bits of infrastructure or different elements of operations could go on their own respective journeys. And it's important to say that it's not just about infrastructure assets, it's also about operations. A digital twin needs to be that holistic view of how you operate, maintain, run your railway. And also it needs to, one of the other challenges we found with this as well, I think when people go into this, they focus heavily on the data, which is good. You need a solid foundation of data to build on. And again, that's one of the things we are focused on, is building that solid foundation of data. But you also need to understand it's a bigger journey. And on the right, you see our digital twin strategy, which was produced towards the end of last year. And that's in that we talk about sort of 5 key pillars to go on this journey. So people, process, structure, connected data, and technology. I think they were all right. But actually, as we go through this, what we realise more is that the people element is going to be the biggest part of this journey we're going on. Client organisation wants to go on it, and I'm seeing more and more now from leadership want to go onto this. There's a real desire to go on this journey, and I think there's a lot of learning still to do about what that journey will entail. But the most challenging part of that is going to be the people. Going on this digital journey, it's as much about how you transform the way you sort of operate and run your business as it is about getting the data right and getting the right tools and tech and the right sensors in place to do that. In terms of I mentioned about sort of being connected into the wider world, we've done some work and Aaron Johnson was seconded to CSIC at Cambridge. Aaron, who presented before, and done some great work. We're producing a paper for the ICE on this at the moment. Aaron's the lead author on that, which is going to be fantastic when that's published. We're also linking in with Centre for Digital Britain and their Digital Twin Hub. I myself also support Network Rail on the what's called the DTG, the Digital Transformation Task Group, which is part of the ICG, the Infrastructure Client Group. So that's a group of clients from across the UK, sort of Heathrow, Anglia Water, and other leading organisations to share best practice on digital transformation. So what we're doing is we're feeding into that, but we're also getting information back. So it comes onto this whole open collaborative approach. And it's important to say as well, TRU is also part of what's called Project 13. So our hope is that as we progress this journey and as we look towards the future, and if Cameron, if you just want to start a quick run through of the model whilst I just give a little bit of view on the future, we're hoping that as we go on this journey, and it is going to be a long-term journey that we go on over a period of time, and we've been very keen to manage expectations with the client organisation on this. This is a significant undertaking to go on, that we will be able to get a smarter, more connected railway where we get the right information at the right time to make the right decisions. But it will be a long-term journey. It's a long-term undertaking. It does need vision, and it needs leadership backing, and it needs real commitment to make this happen. But from myself, I started out as a civil engineer. My asset management journey was civil engineering, and then moved into asset management because it made sense as a civil engineer. So I was one of those that went on that civil engineering journey. But I see the power of things like a digital twin and the connected environment we're creating as giving such fantastic potential in terms of how we can better operate and maintain the railway. And as asset managers, how we can make better, more informed decisions, ultimately sort of helping that, that balance of cost, risk and performance, and helping our clients to make more informed decisions, better value for money. But the other challenge we've got as well at the moment, there's a lot of hype, there's a lot of uncertainty. I think in the past, there's been potentially over-promising with capability. It's great to see iModel that Cameron's displaying at the moment, and I think this is really an evolution of where sort of BIM CAD has moved to at the moment. I think 10 years ago we were talking about BIM will change everything, and I think people maybe felt that didn't quite get there as quick as people hoped it would, whereas now tools like iModel are actually making it open accessible. The fact that you can now open a 3D model in your browser, have that connected to asset data in the background with a central data warehouse, and you can start pulling loads of really useful information from that. It's fantastically powerful. So I do think we're now starting, some of the technology, the tools and the thinking is all starting to coalesce together at the right time, and I'm hopeful that TRU is going to be a program that allows us to actually realise this sort of merging of different things together at the same time. So I hope that was useful and informative. Happy to take any questions on digital twin and sort of our digital twin journey, if there are any. And what I'll do now is hand you back over to Richard Rayson. Thank you very much.
Hi there, everyone. Yeah, it's time to answer some of your questions. So we've got a couple in. In the meantime, yeah, feel free to add a few more to the questions panel. There is a button. It looks like two speech bubbles with a question mark in it. If you hover over your screen, get in touch with your questions. Say all the team are happy to take as many questions as we can before we come to an end. And hopefully you've enjoyed this. So the first question I have, I think it's possibly one for Graham. This is from Gary. Thank you, Gary, for submitting the question. It says, are there any long tunnels on this project? If there are, what train speeds are they going to be designed to? And is there aerodynamic modelling for assets in the tunnels?
Okay, thank you, Richard. So across TRU there are 8 tunnel sections, the longest of which is at Standage Tunnel, which is approximately 3 miles long. And for Standage Tunnel, the programme is looking to potentially increase the line speed through the tunnel from 80 miles an hour to 100 miles an hour. It's not so much aerodynamic modelling that the programme's looking at, it's more timetable modelling to see what benefit that increase in line speed would deliver in terms of journey time, and evaluate the sort of value that the increase in journey time is costing per second, effectively. So if it's costing an inordinate amount of money to achieve that increase in journey time, then the line speed enhancements necessary to deliver that increase in line speed would probably not go ahead. But where it can be proved to be value for money, then the program is looking to deliver such line speeds. The other challenge with the tunnel sections is to do with gauge clearance in respect of planned electrification works, and currently the program is not looking to electrify through Standedge Tunnel, but we are still evaluating the potential cost of doing that if it can be proven that there is economic benefit in that. So I hope that answers the question, Gary, and back to you, Richard.
Great, thanks, Graham. Next question we have is from Kevin, and this is directed at myself. Kevin asks, how was sustainability prioritised and valued in the lifecycle cost process in terms of option model selections? Now, I suppose, Kevin, and everyone, the important thing is that the requirements from Network Rail at this stage is around the lowest lifecycle cost option, which the intention is, if it is the lowest lifecycle cost option over a 100-year period, it should be the most sustainable. However, what I would say is one thing that we are doing within all the analysis that we do, when we create the report, the outputs from the model enable an annualized cost profile. So what that enables us to do is have a look at the cost profile and see how different interventions, whether an intervention is planned on a viaduct or something, actually changes the cost profile and will incur a bow wave of work in future. So, for example, not intervening on a bridge or a viaduct may actually result in greater costs over a few years, or a particular spike in costs somewhere down the line, which are then essentially within the reports. These are highlighted and passed back to the designers, so as we enter this next stage of detailed design, so the designers have got their hopefully lowest lifecycle cost option selected. Moving into the detailed design, they can then look at that and see how they maybe adapt these things to enhance it. But however, there isn't necessarily a firm requirement. These are all lessons which are, of course, being fed back throughout the process, and things we draw ideas from and conclusions when we look to improve process in future. Yeah, so I hope that answers the question satisfactorily. Next question we have is from Ian. It's one for Ross. The question is, what system or method do you have in place to ensure data quality for maintenance and inspection teams?
Hi, good evening. Thank you, Ian, for your question. So the ultimate responsibility for the data quality doesn't actually lie with the project, but does actually lie with Network Rail themselves. It is their job and their team specialising in that. However, what we do have a responsibility for, particularly as us, is as Aaron and the teams are using this data for analysis, we have a need to understand that quality and be able to understand what impact it has on the modelling. So while we cannot directly be responsible for that, we would be stepping on someone's toes that's outside our remit. We have to understand that is. So what we come up with is a series of processes where that's either systematically through the data warehouse, reviewing it and doing large-scale comparison to work out wherever the data is different from the normal. So as I was saying, with the modelling and the scale of the data, we aren't trying to cleanse single data. What we're saying is that we're actually just trying to improve. So one of the analogies I use is we have 10 work orders. We come up with an algorithm. One of them is right, 9 of them are wrong. Now, if I could flip that by doing something algorithmically, now 9 of them are right, 1 are wrong. Now, for the scale of things I was saying is Network Rail themselves will be responsible for getting that 100% right. But for us and the modelling that we're doing and the algorithms that we do, just the fact that there's that significant improvement we can deal with that and do that. So we just use some simple asset classification based queries, but we use the whole data set to train that. Hopefully that was a bit of a null answer, but hopefully that will be a bit more informed on how we tackle that. Thank you.
Okay, thank you guys. Thank you, Ross, sorry. Okay, so at present, haven't got many more questions coming in. I'll give it a few more seconds, a little while longer, just to see whether anything else comes in. In the meantime, what I will say is, from the NXTGen committee side of things, is that these are the sorts of events we try to put on as much as we possibly can to be informative, to hopefully all people new to asset management can engage in them, draw something from them, learn a little bit about something, draw some ideas that will really benefit their careers, and engage with more people in asset management. If you do have any colleagues, people who are new into asset management, please recommend they join NXTGen. It's great to have new members, it's great to put on these events, and hopefully that will enable us to actually run significantly more events in the future. Hopefully this has been hopefully you're happy you enjoyed this one. It's hopefully it's been a success for you. It's our attempt at undertaking an on-site insight in this new normal, as we say. So if you do have any further questions on that, you can contact me directly. I'm richard.rayson@jacobs.com, available on LinkedIn, everything else. And I'll just give it a few more seconds. If there is no more questions coming through, then we'll draw it to a close. I hope you've all enjoyed yourselves and gained something from this. There we go. One more question. Excellent timing. Thank you, Leonie. So the question. Okay, so the question is one for Aaron and possibly Graham or Blair, saying, how does PRAM model consider both the individual assets and the assets as a system, i.e. whether the delay is due to track, drainage or geotech?
Hi, Richard. Yeah, I'll try and answer this. Thanks, Leonie. So yeah, so with the PRAM modelling, and I alluded to it earlier on, it's very output driven, looks at the high level causes and gives a before and after effect. But with this, we've done many complementary analyses. So one of them, for example, is a workshop for Mika with the maintainers who go out on the track, day in, day out, and they know the assets best. And what we do is we compare what they tell us is happening against what the model is telling us to validate the model, but also give us that insight as to what the underlying root cause is. And as you say, every asset interfaces with one another as a system. And sometimes, and we've seen it with the model itself, it can suggest, for example, that a renewal in the rail would be best, but when we look into it, the underlying root cause is due to drainage, for example, which is why the model is only a decision support tool used to inform the designers, and we always encourage them and the engineers to do their own investigation to make sure that their conclusions align and corroborate with our findings. Thank you.
Excellent, thank you, Aaron. Anyone? Is there someone else going to comment?
Well, I was just going to say, just to sort of follow on from Aaron's comments, we also look at overlapping issues in the same area. And for instance, you might have a lot of drainage issues in a particular tunnel, but also have track circuit failures in that section. And to eliminate the track circuit failures, the action would be to prevent the drainage issues, because obviously a track circuit is an electronic based piece of equipment which doesn't fare too well when it's submerged underwater. So we do look holistically at all of the issues in a particular section of the railway, as well as diving deeply into specific asset groups as well.
Excellent, thank you, Graham. Okay, so I think I have no more questions at the present. Just give it a few seconds to see if anything else
Thank you.
Thank you.